for numbers where you have like 25 or 100 intervals, you certainly don't want to calculate by hand the area of 100 rectangles and add them up, unless you've got a calculator. And I'll show you that on Desmos later, that you can do this on Desmos. But the key is to develop a formula for the sum of n rectangles that depends only on n, and then you can substitute these numbers into that formula and get your area. So how do you do that? So here's the graph of x squared plus 1. That's the function. I've depicted dividing the interval from 1 to 4 into just 2 rectangles to give us the idea. So first of all, and I'm using right-hand endpoints because that's the easiest. If you have to follow this technique for left-hand endpoints and midpoints, it gets even messier. But first of all, we need a formula for the width of each rectangle. And that's going to be the right-hand endpoint minus the left-hand endpoint divided by the number of intervals. And we're going to divide it into n rectangles. So this n is the number of rectangles. In this case, 4 divided by 2 would be 2. So that's the width of each of these rectangles right here. Oh, actually, no, it would be 3 halves, or 1 1/2. Yeah. Okay, so now I misspelled formula here. What's a formula for the ith right-hand endpoint? Well, if we start at 1, picture a number line here. We're starting at number 1, and we want to get to this ith right-hand endpoint. X of 1 would be 1 plus one of these widths, 1 plus 3 over n, which you could write like this if you wanted to. And to get to the second right-hand endpoint, you'd start at the left-hand endpoint and add on 2 of these widths. So 1 plus 2 times 3 over n. And then here's a formula for the ith right-hand endpoint, 1 plus I of these 3 over n's. That takes you out to here somewhere. So this is x of I. We've added on I of these guys. I 3 over n's. Now, what do you do with those right-hand endpoints? Well, you plug them into the function to get the height of the rectangle. So the height of the rectangle, we're going to plug this number, or this expression, I should say, into the function, simplify it a little bit, and here's what you get. So for the height, I angle 9i squared over n squared plus 6i over n plus 2. You can follow along down there. Now, here on board 3, once we've got the height, we need a formula for the area of the ith rectangle. Well, the formula for the area of a rectangle is length times width. And this is the height right here, and the width is 3 over n. So if I multiply 3 over n times that expression, I've got a formula for the area of the ith rectangle. There it is right there. Add up the areas using summation notation. So the sum from I equals 1 to n of all these areas looks like this. And at this point, we're going to use summation properties, separating the terms and moving constants out front. Remember, n is just a constant. It's the number of rectangles. So I can picture moving 27n cubed out front and do the sum from I equals 1 to n of I squared. Same for this term, move the 18 over I squared out front. Sum from I equals 1 to n of just I. And here, sum from I equals 1 to n of just the number 1. We'd have n 1s, so this actually reduces to an n. So on the next board, what we're going to do is use summation theorems to replace the summation symbols with the equivalent expression in terms of n. And here's your formulas right here. These can be proven using mathematical induction. So if you have the sum from I equals 1 to n of I, 1 plus 2 plus 3 plus blah, blah, blah to 25, you'd put 25 in here. And that would be the sum of those 25 terms. And here's one for the sum of I squared. So we're replacing these symbols right here, or these expressions, with their equivalents in terms of n. And as I said before, this is just an n. Okay, so what do we got? We're going to simplify this a little bit, and I'll let you just see if you can follow along how we get to here. You could simplify even more if you wanted to, but here I've typed in that formula on Desmos and said, what's a sub 5? Well, it's 717/25. That's the area of 5 rectangles using right-hand endpoints. It's a decimal 28.68. You can look at the rest of these, see if they compare with, if this one compares with your answer. And here's the exact area using a definite integral, 24. Okay, so if I quickly share my screen, go to Desmos. Here's a Desmos graph that does Riemann sums. There's the function x squared plus 1. A and B are the left and right-hand endpoints respectively, 1 to 4. C controls whether using left-hand endpoints, right-hand endpoints, or midpoints. We used right-hand endpoints. There's the width, b minus a over n. Here's the number of rectangles. So as the number of rectangles increases, the area, approximate area, gets closer and closer to the exact area, which is 24. Okay, so there's the 100. All right, so I'll post a link to this graph in the answer. There you go. Hope that helped. If you have any questions, post a comment.